Hello and welcome to this video where we will be discussing router on a Stick Inter-VLAN routing. If you are someone who is new to networking, you might be wondering what VLANs are and why they are used. Virtual Local Area Networks, or VLANs, are a way to segment a network into logical groups, allowing for more efficient use of network resources and improved security. However, in order for VLANs to communicate with each other, we need a way to route traffic between them, and this is where router on a stick comes in. Let us configure some VLANs on a Cisco 2960 switch. So what is router on a Stick Inter-VLAN routing? Essentially, it is a method of routing traffic between VLANs using a single physical interface on a router. This is achieved by creating sub-interfaces on the router's physical interface, with each sub-interface assigned to a specific VLAN. The show VLAN brief command is a Cisco iOS command that displays a summary of VLAN information for all VLANs configured on a Cisco network switch. This command provides a quick and easy way to view basic information about each VLAN, such as its VLAN ID, VLAN name, and its status, active or inactive. I like using this command to check the interfaces on a Cisco switch. Let us now place some ports on the switch to their respective VLANs. We need to configure the switch ports that are connected to each VLAN to be in access mode. This means that each port will only carry traffic for its respective VLAN. As you can see, port 3 is now in the marketing VLAN. Let us add another port to a VLAN. Let me now add some computers to the switch. I will connect three computers. Two will be in VLAN 2 on ports 1 and 2, and one will be in VLAN 3 on port 3. Let us now configure IP addresses on the computers. Let us now try pinging from one computer to the other. Computers 0 and 1 are in the same VLAN, so the ping will be successful. PC1 won't be able to ping PC2 because they are in different VLANs. We need to create a way for these VLANs to communicate with each other. This is where router on stick comes in. So let me add a router. As you can see, port 4 is not yet connected. We need to run the no shutdown command on the port on the router. Before we do that, let us configure port 4 on the switch as a track port. His will allow multiple VLANs to pass through a single physical interface. Next, we need to configure the router's physical interface that is connected to the switch. Then, We create sub-interfaces on the router's physical interface, with each sub-interface assigned to a specific VLAN. We can place an IP address under the physical interface. The result is that frames sent from the IP address will be untagged. The frames will be a member of the default VLAN, that is VLAN 1, the management VLAN. This means the address we configure here is the native VLAN IP address for the switch. The IP will be the default gateway for VLAN 1. Let us now create sub-interfaces on the router's physical interface, with each sub-interface assigned to a specific VLAN. You can set the sub-interface to trunk with the encapsulation command. This router only supports 800 and 2.1T. Only older routers run the ISL encapsulation. The sub-interface number is only locally significant, so it doesn't matter which sub-interface numbers are configured on the router. I mostly configure a sub-interface with the same number as the VLAN I want to route. It's easy to remember that way since a sub-interface number is used only for administrative purposes. Let us now add the IP addresses we configured on the sub-interfaces as default gateways for computers. Then we can try pinging from one VLAN to the other. Let me now ping the default gateway we created on the router for the VLANs. As you can see, the ping is successful. Let me now ping from one VLAN to the other. Traffic is now being routed between the VLANs using the router's physical interface as the connection point. And that's it. Router on Stick Inter-VLAN routing is a powerful method for routing traffic between VLANs using a single physical interface on a router. It allows for efficient use of network resources and improved security by segmenting the network into logical groups. If you have any questions or comments, please leave them down below. Thank you for watching, and I'll see you in the next video. Please subscribe to my channel. This will help my channel to grow.